equals 900. For how many positive integers m is y over m an integer? First of all, the problem states that y over m is an integer. Which of the following about y and m must be true? If this quotient is an integer, then m is a factor of y. So, the problem asks us to find the number of factors of y. Is there a formula to apply? We need to apply the formula of number of factors. First of all, we need to find the prime factorization of y. Y equals 9 times 10 squared. Y equals 3 squared times 5 times 2 squared. Finally, y equals 3 squared times the exponent can be distributed like this. So this is 5 squared times 2 squared. This is the prime factorization of y. Once we get the prime factorization, we need to add 1 unit to each of the exponents. 2 plus 1, 3, 2 plus 1, 3, 2 plus 1, 3. And finally, the number of factors of y is the product of these numbers. 3 times 3 times 3, 27. Choice D is correct. Carmen is buying nuts and bolts at a local hardware store. The store sells nuts in packs of 12 and bolts in packs of 10. If Carmen wishes to buy the same number of nuts and bolts, what is the smallest number of nuts that she can buy? Now, we know that nuts are sold in packs of 12 and bolts are sold in packs of 10. Therefore, if Carmen wishes to buy the same number of nuts and bolts, the smallest number of bolts she's allowed to buy can be found by calculating the least common multiple of 10 and 12. Divide both numbers by 2, 5 and 6. Divide 6 by 2, 3. This one stays the same now. Over 3, 1, 5 and over 5. Finally, the least common multiple equals the product of all these prime numbers, that is 60. Letter D is our answer. Which of the following cannot be the greatest common divisor of two positive integers a and b? Well, first of all, let's make the following assumptions. If a and b are different prime numbers, for instance 3 and 5, the greatest common divisor of a and b is 1. Therefore, alternative A is eliminated. Now, if A is less than B, then the greatest common divisor of A and B must be less than or equal to A. For instance, let A be 4 and B be 8. The greatest common divisor of 4 and 8 must be less than or equal to 4. In this case, the greatest common divisor is 4. It means that A is a possible greatest common divisor of A and B. Alternative B is eliminated. Now, alternative C is eliminated as well for the same reason. If B is less than A, then the greatest common divisor of A and B must be less than or equal to B. Now, what about alternative D and E? According with the assumptions, can the greatest common divisor of a set of numbers be greater than at least one of them? Since the factors of an integer are always equal or less than the number itself, the greatest common divisor of A and B cannot be greater than A and B. Therefore, choice E is correct. A plus B is greater than A and B, and a factor cannot be greater than the number. If the greatest common divisor of M and 210 is 7, then which of the following could be a value of M? So the problem states that the greatest common divisor of M and 210 is 7. Therefore, 7 is a factor of M. In other words, M is a multiple of 7. Is a multiple of 2, 3, or 5 a possible value for M? The greatest common divisor of M and 210 is 7. This sentence also means that M is not divisible by 2, 3, or 5. In other words, M cannot be a multiple of 2, 3, or 5. Otherwise, the greatest common factor of these two numbers would be greater than 7. Thus, our answer must be a number which is not a multiple of 2, 3, or 5, but a multiple of 7. Alternative A is discarded because 11 is not a multiple of 7. Alternative B is discarded because 14 is a multiple of 2. Alternative C is discarded because 21 is a multiple of 3. Alternative D is discarded because 35 is a multiple of 5. Finally, choice E is correct. 77 is a multiple of 7 and is not a multiple of 2, 3, or 5.